Hello everyone, my name is Miss Shahbazi and I'm teaching math for high school students for a long time. I'm gonna work on grade 11 math with you and we already had two sessions. It's our third session and we are talking about the different type of a function. We talked about the function notation, function and relation, the differences, how we can recognize which one's a function and which one's not, and also domain and range. They were the subjects that we went through it. Here, I'm gonna continue the lesson. Before like I continue for the lesson, I would like to let you know that the company, OneClass company, is offering 100,000 hours of the free one by one tutoring session, online session that you can sign up for it. The link is on there, and also you can see and find the information online too on like a company's website. Okay, I'm gonna start to go for the lessons and see what we learned and what we had it from the last class. Last class, after going and continuing like for the function, we had a last part as a polynomial, adding, subtracting, and multiplying a polynomial to each other. Today we are gonna start with the factoring. They are the topics that you learn on grade 10, and here because we need it again to use them, it's the reason that I'm gonna go over them, making sure that you know the topic very well. Lesson 4 is starting with the factoring review. If you remember, factoring, it's almost is opposite direction of doing the expanding. Expanding, we are multiplying two brackets or couple of expression together. Here we are trying to do one expression in couple of multiplication. For example, here 2x squared plus 8x, as you see, having a common variable. 2 for the number is the common between 2 and 8, and x squared and x, that easily we can say that okay, the common is 2x, and if I factor 2x is gonna be x plus 4. As you see, I turn one expression to a multiplication of two expressions. This type of factoring that we were looking for the common factor between two terms, two or like any terms that we are naming common factoring. We have another terms, we have another like explanation for making it easy factoring. There's a rule for perfect square trinomial. Here is just talking about that x plus a by power of 2, can write it down as x squared plus 2x plus a squared. It is a one of the perfect square. Another one is x minus a by power of 2. That's x squared minus 2ax plus a squared. Now we want to try to do this example. I know that there is a three terms here. I have a 9x squared. I'm gonna assume this is I can easily write it down a plus minus b in a short form. Okay, here as you see is gonna be a normal and general formula for perfect square. Here I have a 9x squared. 9x squared can be my a square. 25 is a b square, and there is an add between them. Then it is a 2ab. If I like to compare this expression with the formula that I have. In that case, as you see, a square is gonna be 3x and b square is gonna be 25, then b is gonna be 5. Let me see. I have a square 9x squared, then a is 3x. 25 is b squared, then b is 5. I have to make sure if 30x is 2ab. Okay, 2 multiplied by 3x, 6x multiplied by 5 is 30x. Then the formula is correct. We have another formula here is a difference of a square that is talking about x squared minus a squared is x minus a and x plus a. In that case, if I like to factor this one, it's gonna be 4x minus y into the 4x plus y. They are the different ways of doing a factoring. I like just to go over it with the solution that I have. That is gonna be much more easier. Another way for the factoring is trinomial factoring. When a is 1, I have expression, trinomial expression, that the coefficient for highest degree x is x squared. In that case, we have a formula that the sum and product means that I am looking for two numbers because I can write it down this bracket as a this like expression as a two brackets. For each bracket, I need a two values here because I am using this formula. Let's see if you can see. It is a sum and product formula that if I have a trinomial expression, I can write it down the multiplication of the two number as a plus b and multiplication as a dot b and sum of them a plus b. Now I'm comparing with whatever that I have here, x squared plus 5x minus 36. Technically I'm looking for two number that their sum is 5 and their multiplication is negative 36. Comparing these two information that I have, I'm looking for two numbers adding up to 5 and multiplication of negative 36. I can say that it's a negative 4 and 9. Multiplication is negative 36 and sum is 5. Okay, then x minus 4 and x plus 9. But this way, this formula doesn't work if the leading coefficient or the a coefficient for x squared is not 1. This one is just working if that one is not 1. Then if I have something like that, let's see what do I have to do. For example, I have a factoring 9x squared plus 3xy minus 2y squared. And let me tell you some things. Make sure for every factoring, the first step that you are taking is a common factor. If common factor doesn't work, then go for the next step. Or sometimes common factor works as a first step, but still you need to do more steps to do more factoring. Sorry. Then now I have, as you see here, 9x squared plus 3xy minus 2y squared. And here a is not 1. In that case, see what am I looking for? I know that the sum of them is S is some of them is 3 here, yes, but product of them is not a just negative 2. Here I'm multiplying this negative 2 with the coefficient of 9 that I have is gonna be negative 18. I'm looking for two numbers that their product is negative 18 and their sum is 3. Okay, negative 3 and 6. This negative 3 and 6 is helping me to break down the middle part. Then 3xy, I can write it down negative 3xy plus 6xy. See? Now I have a like a expression with four terms. I can do factoring by grouping first common factor. 9x squared minus 3xy, I can factor 3x, then it's going to be 3x minus y, and 6xy minus 2y, I can factor 2y, then it's going to be 3x minus y. Again, common factor, here as you see 3x minus y and 3x minus y is a common factor. Then I can use a 3x and 2y adding up together, and 3x minus y is going to be as a common factor sitting beside. Then steps to follow to factor a given polynomial. Take out any common factor. It is the first and the main, because I see that so many students are keep forgetting this one, common factor. They are starting to do factoring without checking if there's any common factor. And most of the time in those cases, you are going to have a bigger expression. And if you like just to start to do any using any formula or whatever, your numbers are going to be big, is not going to be that easy. Determine if polynomial or is not a perfect square or difference square. Then the first step, common factor. After that, we are going to check if it's a perfect square or difference square. If it is not, then we are going to check the sum and product. Sum and product if the a is 1 or if the a is not 1. And sometimes we do not have for the step 3 or step 2 that we are using perfect square or difference square or sum or product formula. As you see, we need to have a trinomial, but not all the time we have a trinomial expression. We may have any polynomial expression. In that case, most of the time, first common factor, then grouping, and into your grouping maybe you can use still any of the formula that you had for the trinomial. Check the factor by multiplying them together. You should get the original polynomial. Now I like just to give you a little bit time, 2 minutes time. Let's see if you can do these 5 questions. 5 questions is gonna be a little bit long. Here we are gonna start. Let's do this one together. The easy one I'm gonna do, then the more challenging one I'm gonna leave it for you. 2x4 x4 minus 9. Here I can see that there is a 2x4 is a common and I could factor it that way. But this factoring is not done yet because the second bracket is still difference square. Then I'm gonna take a next step. After this point, I'm done. X squared plus 3 is not factorable. X squared minus 3 look like a difference square, but 3 is not a square rootable. Then it is the end of my factoring for this question. How about next one? Is a trinomial. I'm gonna check if it is a perfect square or not. X squared Okay, look like that's a perfect square. I'm gonna check the last one, 22. 22 is not a square for any number. Then for sure this question is not a perfect square. And as you see, there is no common factor that I can do. Then I have to use a sum and product. I gave you a hint, is your term. Go ahead. Let's see if you can do this question. Could you figure out? Sum has to be negative 9. Product has to be negative 22. The only two number coming to my mind is negative 11 and 2. Then the answer is gonna be x minus 11, x plus 2. How about part C? As you see, on part C is a bracket, folks. On part C, there is no common factor that I can do. Okay, it's a 6x square and 5 at the end, then for sure it's not a perfect square or difference square, because difference square needs a two terms. This is a three terms, and the first and last terms, they are not a square. Then the only things that I'm thinking is a sum and product. A is not 1. If A is not 1, I'm gonna use another method like S and P and they are gonna be difference. S is negative 7, but P is gonna be negative 30. I'm leaving it here. You try to do by yourself. Let's see if you can do. Could you get the answer? I'm giving a next step to you. Negative 10 and 3 look like. Negative 10 and 3 makes negative 30, and their sum is. I do not have enough space here. I'm just writing it here. You may say that why did I write it on 3x first and negative 10x? When I'm writing these two terms, I'm just thinking about that, okay, I have to factor as a next step for the grouping. If I put it like a 10x here, still I could factor. But 3x, if I wrote it down these two in opposite direction, 3x and 5, I wouldn't find anything to factor, common factor. Then when I'm writing my two terms based on the number that I got here, I will try to put the number beside of a term that I can make a common factor. Now, I'm just using a different color. Let's see. Here, I can factor 3x, 2x plus 1. And here look like that I can factor negative 5. Now, 2x plus 1 is a common between them. That's it. For the next two questions, I'm not gonna say any hint or whatever. You try to do by yourself. Good? And I'm giving you 1 minute, one full minute. I'm just watching the time. 1 full minute's time. Go ahead. Okay, you had your full 1 minute's time. Let's see what did you got. Here, x by power of 4 plus x squared minus 20, x by power of 2 minus, because it's look like that, I'm gonna count it as a equal by 1. Sum of them has to be 1 and the product is gonna be negative 2, negative 4 and 5. X squared minus 4, x squared plus 5 is not done yet. X squared minus 4 is factorable more based on a difference square. Here I have a 4 terms polynomial. In that case, I'm going to do just grouping. Grouping of first two is going to give me x plus 2 and 3x squared and x plus 2. After factoring, I'm going to have a 3x squared plus 1 to x plus 2. Hopefully that all of you could get the answer correct. Here is just like a overall um, summary of factoring. Polynomial factoring, the factoring is a common factor that we have to do. Factor out the greatest common factor is the first step for all of the factoring. Then we have a monomial that it's a one term. These type of like a relation or expression, they are not factorable. Like a x squared is a one term. You cannot factor it. You can just leave it as it is. Then these ones are not factoring. Then next type of a polynomial are binomial, that they do have a two terms. These two terms, there is a two options for them. Two perfect square, that if it is a two perfect square, I'm gonna just say that it's a difference square. That is a squared minus b squared, and you know the formula. The other one is a sum between them, like a squared plus b squared. In that case, those ones are not factorable as well. For binomial, for two terms, there is another way of factoring. It's a two perfect cube. If it is a two perfect cube, means that exponent 3, then I have a two options. If there is a difference between those cube or sum, both of them are factorable based on a difference of cube and sum of the cubes. And as you see, the formulas are here. After binomial, we have another one, trinomial. Trinomial means that there is a three terms. For three terms, we have an option of a perfect square. In perfect square, I have a squared plus 2ab plus b squared that makes a plus b by power of 2 and a squared minus 2ab plus b squared a minus b by power of 2. Or we can have a general trinomial ax squared plus bx plus c that we talked about it, that if this a is 1, sum and product, and if a is not 1, we are using a decomposition. Finally, if it is a 4-term polynomial, always we are doing factor based on a grouping. It is like a 1 over view. I'm just trying to make it small that you can see in a one picture. I'm not sure if you can just take a like a screenshot or the picture and then maybe zoom it bigger, or if I was you, I was writing a full like a chart for myself, then I can remember for future as well, easier to follow. Okay, now we are going for the radical numbers. Radical sign is whatever that we may say it or we saw it before, and maybe we saw it and we said to it square root. Technically is not a square root, it is a radical sign. We are naming this one a square root because there is a hidden 2 here. The index is 2 here. Like when I'm talking about a number like a, when there is no exponent, everyone knows that the exponent is 1. If there is no denominator, everyone knows that the denominator is 1. No coefficient, 1. Then a by itself has exponent 1, coefficient 1, and denominator 1. And we are not writing any of these ones. Same things for radical. When you have a radical that there is nothing on it, like there is no index here, everyone knows that there is an index is 2. But if there is an index another number, you have to write it an index. We have a index 3, index 10, index of any number. Yeah? Then the number or expression under here, I'm just going, the number or expression under radical sign is called the radicand. If the radicand is greater than or equal to 0 and is not a perfect square, then the radical is an irrational number. An approximate value can be found using a calculator. However, in many situations, it is better to work with the exact value. Let me make it a little bit bigger. I made it small for the... Okay, I believe so. It is much more easier to follow. Sometimes entire radicals can be simplified by removing a perfect square factor. The result expression is called a mixed radical. Like what? A radical 10, a radical 8, or radical are example of entire radicals. They are in a form of radical n. But the radicals, 3 radical 2, 6 radical 5, as you see, is a mix of a number before radical and radical. These ones are example of a mixed radical that we can write it down a radical b. The radicals 3 radical 5, negative 7 radical 5 and radical 5s are like radicals. Why? Because all of them are using a radical 5 here. Okay, not just a radical 5, any radical with the same number. For radical, we know that we can multiply two radicals to each other if their index are same. We can divide radicals if their index are same. Here there are some example for mixed radical to how we can express the entire radical to a mixed radical as a in simplest form. For example, here I have a radical 50. Radical 50, I can write it down 2 multiplied by 25 for 50. I know that radical 2 and radical 25, based on the law that I have here, I can write it down. Radical 25 is a perfect square radical. I can take it out. It's gonna be 5, and then but for radical 2 I can't do anything. It will stay under radical. Then it's gonna be 5 radical 2. Let's see if you can do next one. For radical 27, what you can write it down? Yeah, you are correct. 9 times 3. How about radical 180? 180 is a little bit bigger number compared with another two example. I'm just thinking what can I write it down for it. Let's see. I'm gonna use this here to simplify 180. 180 can be divided by 2. Then it's gonna be 90. I'm just trying to find the factors for 180. 90 can divide by 2 is gonna be 45. 45 can divide by 3, it makes 15. 15 divided by 3, it makes 5. And finally 5 divided by 5 makes 5. Then for 180, I can write it down 2 by power of 2 multiplied by 3 by power of 2 multiplied by 5. Here 2 by power of 2 3 by power of 2 2 by power of 2 under square root or radical is gonna be 2 and this one is gonna be 3 and I can multiply these two. But radical 5 is staying on its place under radical. We can add and subtract radical. Here we just talked about the multiplication or division of the radicals. Here we have a couple of questions about the adding and subtracting radicals. Here I'm gonna start with the first example. 12 radical 6 plus 5 radical 7 minus 3 radical 6 minus 11 radical 7. Radicals, you can add them together if they are like radical. You cannot add up like a radicals that they are not like. Then these two can be add up together and the blue one can be add up together. Then 12 minus 3 is gonna be 9 radical 6, and 5 minus 11 is gonna be minus 6 radical 7. And I cannot simplify this radical more than this. I'm gonna leave it as it is. Going for example B. Example B is a nice example because first you have to simplify or you can make the radical to mixed radical. A radical 50, I can write it down, you saw it before, 25 times 2. A radical 27, you can write it down 9 times 3 minus For radical 32, you can write it down 16 times 2. And for 300, I can write it down 100 times 3, yeah? Make sure that you have a radical to the end of your last number. Here, I can write it down 5 radical 2 for this one. For the next one, I can write it down 3 radical 3 minus 4 radical 2 and plus 10 radical 3. In that case, I changed all of these like a full radical to the mixed radical. Now 5 radical 2 minus 4 radical 2 is gonna be a radical 2. 3 radical 3 plus 10 radical 3 is gonna be 13 radical 3. Then we learn about that, okay, adding, subtracting for radical is gonna be happen if they are alike radicals. But for multiplying and division, you can easily multiply two radicals that they are not like together or divide them. Let's see here. I have a next example, multiplying radical. To multiply radical, multiply the number outside of the radical sign. The only like a restriction that we have for multiplying a radical, number outsides are multiplying together, number on the radical, they are multiplying together as well. Then here, for example, I'm gonna have there is no number beside, then nothing. Radical 20 multiplied by radical 5 is gonna be radical 100. Oh, I know the answer. It's 10. How about another example here? 9 times 4 is gonna be 36 and 2 times 7 is 14. It is a mixed radical and I cannot simplify more because radical 14 is not like a breakdown to any another number that I can factor. I'm sorry, I can do the square root. How about here? Same skills that you had for expression is applying for here radical as well. 5 multiplied by 4, 20. And radical 3 multiplied by radical 6 is radical 18. Plus 5 multiplied by 2, 10. And radical 24. I'm done for multiplication, but look like this question maybe is simplifiable. Radical 18, I can write it down as a 9 times 2. And 9 is square rootable. How about 24? 24 can write it down 4 times 8 times 3 or 4 times 6. 4 times 6 is much more better. Now here I'm gonna have a radical 9 that is gonna make 3 for me. 3 is multiplying by, let me write it then step by step. And I cannot simplify more than this. I'm giving you like a 30 seconds. Let's see if you can start and do next question. This one is gonna be FOIL method is a hint to start. Go ahead. Okay, let's see if you did it correct. Okay, yeah, you had to use the FOIL method. 4 times 2, 8, radical 3 times radical 3, radical 9, 4 times negative 5, negative 20, radical 3 to radical 2. Radical 6, 2 times 2, 4, radical 6, and 2 times this one, negative 10, radical 4. Radical 9 and radical 4, I know what are the answers. And then 24 minus 20, and I have a negative 20, radical 6, and 4, radical 6, that they are alike radicals, that I'm gonna add them together. It is my final answer. Now we are going to the next lesson. Is a radical, still is a radical. But if the index is not 2, the same things that I was just talking to you. Technically, radical number are not restricted to a square root. You can actually take the nth root of function. The number. And you can write it down as this format. The nth root of a number. Since the square root is used so often, the index is omitted. However, for all other roots, we must specify the index outside of the radical sign. Here there are some examples. This example, I prefer to go from the solution because they are not that hard. Okay. Here, as you see, I have a cube root of 8. Cube root of 8 means that 2 times 2 times 2. 2 is 3 times multiplying by itself. Then 2 by power of 3, and the index is 3. They are going to cancel out each other. It's going to be a 2. How about cube root of 125? 125 is going to be 5 times 5 times 5. Then technically it's a 5 by power of 3. You can write it down. Let me. For 125, you can write it down 5 by power of 3. And these two 3 can cancel out each other. The answer is 5. Look at part C. Cube root of 27. Then it's going to be 3 times 3 times 3. Means that, okay, it is a 3 by power of 3. And these two 3 can cancel out each other. I'm going to have a 5. 81 root 4th root of 81. 81 is 3 by power of 4. 16 is 2 by power of 4. 625 is a 5 by power of 4. We are not expecting you to know some things like that. You can use your calculator to calculate. But like for 125, 8, 81, or 27 or 16, we are expecting the students in grade 11 knows this stuff. Okay. Let's see if I have a question like that. What do I have to do? 108 minus 108 cube root of 108 minus cube root of 32. Let's see what can I write it down for these ones. 108, I can find the factor of 108 is gonna be, I believe so. Let me make sure. I'm a student. 2, 54, 2, 27, 3. I know 27. Do I have to continue? No. You can write it down. Mm, I'm so sorry. I like just to write it down 27 first. How about 32? What can I write it down for 32? I didn't like this one. I didn't write it in the proper way. I like just to write it in a better format. How about 32? What can I write it down for 32? 32, isn't it 8 times 4? I believe so. Okay. Cube root of 27, you saw it before, is a 3 times 3 times 3, then it is a 3. But there is no root 3 for 4, then 4 is staying under radical sign. Here, 8 cube root is going to be a 2 because 2 times 2 times 2 is going to give me a 8. Then 3 minus 2, then the answer for this question is going to be radical 4 index 3. How about next question? For next question, because the question is asking simplify, first step that I'm gonna take is do inside of the bracket, bed mass, first inside of the bracket. What can I write it down for 40? 40 is 8 times 5. But another 5, it's a prime number, is not factorable, there is no common factor for it, it's going to be a stay as it is. 8 cube root is going to be a 2. Two minus 1 is going to be 1. And the final answer is going to be the final answer for this question. Here there's a chart for the perfect cube and perfect like a cube root. It's a 1, 8, 27 to 1000. Then you have to know what is the cube root for these numbers. Here there is a perfect cube for negative number as well. If you remember, we were saying that, okay, if I had a negative 25, I couldn't answer because negative under square root wouldn't have any meaning. We said that, okay, we cannot do this one because of the negative under square root. You are gonna learn, I'm not sure today, but you are gonna learn that, okay, you can solve this type of a question too. But when it goes for the index 3 or any odd index, you have a negative number. Why? Because this negative 8 is a multiplication of negative 2, negative 2, and negative 2. Same number is multiplying 3 times by itself. Then easily I can give the answer. But negative 25, you cannot find any two same numbers making multiplication of negative 25. For example, for negative 25, you may have a positive 5 and negative 5. You cannot have a two same numbers. It is the reason that you do not have an answer here, but here for cube root, you have a negative value. Then as a conclusion, we can say for the negative number on the radical, if the index is even, there is no integer number, there is no simplifying as a uh, numbers coming out of the radical. But if there is an odd index, you can have a negative and positive number on the radical and you can get the actual answer. I like just to start to go a little bit talk about the rationalization. We have a couple of minutes, then we can talk about it. The lessons that I'm going over it is a good lesson. You are gonna use this one in your calculus as well. Then it's very good that you have a good base right now. Then when you are going to the calculus class, you know the topic and everything. Here we are talking about the rationalizing denominator. For whatever reason, it is generally considered poor form to leave a radical in a denominator. Most of the time we are trying just to keep radical in our numerator, not on denominator. Then we are trying to the process of getting rid of radicals in the denominator. And we are naming this one rationalizing the denominator. In some cases in the future, you are going to see that you may need to rationalize your numerator as well. But here we are going to work just on the denominator. Rationalizing numerator or denominator, both of them, we are using same method. But majority of the time we are doing a rationalizing denominator, and here we are doing a rationalizing denominator. A radical is the simplest form when the radical has no perfect square factor other than 1. The radicand does not contain a fraction. No radical appears in the denominator of a fraction. It is a simplest form for a radical. For example, I have a 4 over radical 6. How can I get rid of this radical 6 at the denominator? It is the steps that we are taking. Here, I'm going to multiply numerator and denominator with the same number. Look like that I'm multiplying a number by 1. And we know that multiplying by 1 doesn't change the value of the number. Here I'm multiplying by a number value 1, but technically here is a radical 6 at the denominator. I choose that number 1 being a radical 6 over radical 6. Why? Because in the next step, I'm gonna have 4 times radical 6 for my numerator, and on denominator, I'm gonna have a radical 36 because radical 6 times radical 6 is going to be 36. And what is the radical 6 value? Everyone knows, yeah? It's a 6. See, I get rid of the radical sign in my denominator. I can do more simplification. 2 radical 6 over 3. What do you think about the next one? For the next one, I'm sure that you are doing at home for yourself, and I'm doing this side here. I'm gonna multiply by radical 5 over radical 5. It's gonna be 175 over radical. Oh, I made a mistake. I could do this question easier than this way. How could I do this question without multiplying numerator and denominator? Here, I could easily say that, okay, it's a radical. Because numerator and denominator, they can simplify. Radical 35 divided by 5 is gonna be 7. There is no denominator and I'm done. Let's see what can I do for next question. I'm gonna check to not make a same mistake that I made. I might do it in part B. Okay, I cached it and I fixed it very fast. For first one, I multiply numerator denominator by radical 6. Second one, I divide it. And here, can I divide? Can I simplify as a first order? No, there's nothing to simplify. Then the only thing that I can do, it is multiplying by some things that I can get right after radical at denominator. I'm not multiplying by 2 radical 3 because there is no problem having a 2 there. I do not have any problem having a integer number. Then the answer is gonna be 3 radical 15 over 2 radical 9. Okay, 2 radical 9 is gonna be what? Radical 9 is 3. Multiplied by 2 is gonna be 6. And I can simplify one more step. 3 and 6 they can simplify. And radical 15 I cannot make it as a mixed radical. Here there are two last questions that I want to do for today. Here we are gonna simplify. To get rid of a radical in a binomial denominator, multiply the number and the numerator by the conjugate of the denominator. Conjugate of a denominator, conjugate is like that. If I have, for example, 3x plus 1, it's going to be 3x minus 1. Then I can use the difference square to simplify. Then in that case, I'm going to multiply by numerator and denominator by conjugate of denominator. Okay, for numerator, I'm gonna have a 2 radical 18 minus a radical 30. I'm so sorry, folks. I like just to stop for a second here. Because we have answer, I like just to go over the answer. It's gonna be much more faster. Here I multiplied numerator and denominator with this one. Then it's gonna be 2 multiplied by 2, 4, radical 3 multiplied by radical 3, 3, and plus radical 5 minus radical 5, so it's gonna be make negative 5. Multiplying numerator and denominator 4 times 3, 12 minus 5, and numerator, when I'm multiplying, I'm gonna have these two number. Radical 18 is simplifiable. Radical 18 is simplifiable. Then I did 2 radical 9 or 3 multiplied by 2, 6. And here radical 30 is staying by 8. So here I have a 2 over 3 plus radical 6 is going to be multiplied by 3 minus radical 6, numerator and denominator. Make 6 minus 2 radical 6 over 3 times 3 is 9 minus radical 6 by power of 2. Here I'm going to write it down the conjugate for you. If you have a plus b, multiplying by a minus b is a square minus b square. Same things that I'm doing here. A plus b, a minus b. The answer is going to be a squared, 3 by power of 2, and radical 6 squared is 6. Then 6 minus 2 radical 6 over 3. Folks, I'm going to stop here today. And we are going to continue for the next class. Is going to be couple of question, and we are gonna work on a complex. I'm gonna pause on this one because there is a couple of more question. If you like to make a more practice, you can have them. Now let me show it to you without solution that you can try by yourself. I'm leaving this page like as a last page that you can work on it by yourself. Have a very good time. Stay at home, stay safe, and I'm wishing all the best for you. See you on next class on Friday, same time.